Okay guys, so we're now starting exponential and log equations. So we're looking at solving problems or solving equations where x is in the power or as part of a logarithm. So in this particular example where we've got 3 to the power of 3 minus 2x, it's equal to 1 over 27. What we need to do is we need to express both sides of the equation with the same base number. Okay, so in this case it's going to be 3. So that'll give us 3 to the power of 3 minus 2x. That doesn't change on that side. But 1 over 27 is the same as 1 over 3 to the power of 3, which is the same as 1 over, which is the same as 3 to the power of negative 3. And this side simply stays the same. Now when we have numbers on both sides of the equation with the same base number, so in this case the same base number is 3, we can just basically ignore those base numbers and we're just left with the powers. So 3 minus 2x is equal to negative 3. So now this is just a matter of solving a simple equation here. So we'll subtract 3 from both sides, which gives us negative 2x is equal to negative 6. Divide by negative 2. And x is equal to 3. So if we move on to another example now. Now in this example we've got x in a logarithm. So we've got log base 4 of 2x plus 5 is equal to 3. Now for this particular example we need to remember that e to the power of x equals a. This is the same as x equaling the log of base e of a. So what we can actually do is we can actually rearrange this so that it's in index form, so that it looks a bit more like this. So what we actually get by doing that is, let's see, so we look at where x is, so x is the subject, so in this example x is the same as 3 here, so that's going to become our new power, so I'm just going to put that there for now. Now the base of the logarithm, which in this case is 4, is the base of the index, so 4 to the power of 3, and a is 2x plus 5 in this example, so that goes to the other side of the equation, which is over there like so. So now again we've got a linear problem to solve. So 4 cubed, I've just forgotten off the top of my head, so we've got 16 times 4, 4 times 6, 24, 4 times 1 plus 2, so that's 64 is equal to 2x plus 5. So now we take 5 from both sides, giving us 59 equals 2x. So therefore x equals, if we divide both sides by 2, x is equal to, another tricky one, 29.5 or 29.5. Or we could have just left it as 59 on 2, which is what they've got in the book. Okay guys, so in this particular example, we need to remember our log laws. So we've got log base e of x plus log base e of x plus 5, and that's equal to log base e of 3x plus 4 plus log e of 3. So remembering our log laws, we know that when we've got two logs with the same base added together, we can simply represent them as a multiplication. So that will give us, on the left hand side of the equation, log base e of x times x plus 5, and that will be equal to log base e of 3 times 3x plus 4. Now, what we can do, because we've got log e on both sides, or natural log on both sides, we just pretend they're not there, and we end up with x times x plus 5 equals 3 times 3x plus 4. So now we can expand the brackets, and then we'll be able to solve it as a quadratic. So we'll end up with x squared plus 5x, and that will be equal to 9x plus 12. And now we want everything on the same side, so we'll subtract 9x and 12 from both sides, and that will leave us with x squared minus 4x minus 12, and that equals 0. So now we need to factorize this as a quadratic. So we can start off with our two brackets like so, and that's going to equal 0. And now we need to find factors of negative 12 that add to equal negative 4. So negative 6 and positive 2 will do the trick there. So our solutions for x in this case, using the null factor law, are 6 and negative 2. So that's how we do that one.